I went ahead and stubbed out the boilerplate code here in a file called Arduino Relay, which should look familiar to you if you have taken my Getting Started with the Johnny 5 Robotics Framework course. I'm using WebStorm here to edit my code, which is certainly not a requirement for this demo, so feel free to use whichever text editor you would like. Alright, so the first step is to pull in the Johnny 5 module, which I've just assigned to a variable called 5. Then, I instantiated a new board object, which corresponds to my physical Arduino board. After that, I set up an event handler for the ready event, which is triggered after Johnny 5 successfully connects to my Arduino. The event handler takes in a callback function that is executed when the ready event is fired, which is where I'll put the code to work with the relay. Now, since there isn't a whole lot you can do with a relay, I'm just going to inject a new relay object into the REPL so that I can work with it directly in a terminal window. In order to do this, I need to access the REPL property on the board object, which is accessible using the this keyword, that's kind of tough to say, since I'm in the context of the board object. Then I'll just call the inject function on the REPL, which takes in an object literal containing properties for any of the objects with which you want to work. Since I'm just going to be working with a single relay object, I'll add a property called relay, and then assign to it a new relay object by calling new5.relay. The relay constructor takes in a couple of different types of arguments, with one of them being a number corresponding to the physical pin to which the relay is hooked up. The other type of argument is an object containing a couple of properties defining the type of relay with which you're working, as well as the pin number to which it is hooked up. But for now, I'll just pass in the pin number where my relay is connected, which is pin number 12. Alright, I'll first pull open my camera window so that you can see the results of the code when it's executed. And then I'll switch over to the shell of power, and then execute the Arduino relay.js file here in my demo directory using Node.js. Okay, since I injected a relay object into the REPL, I can access it using the relay property I added to the object literal passed into the inject function. Now the relay object is really simple and only offers 5 functions with which to work: open, close, on, off, and toggle. The on function tells the relay to close the circuit with which we want to work so that whatever device is wired up to the terminals turns on. Since I have 2 lights wired up to my relay, it may be a little confusing as to which light should turn on when this function is called, so to clarify, the goal is to turn the green light on when the on function is called. Now generally speaking, you'll probably only have one circuit wired up, which will more than likely be the NO circuit, so this won't be much of an issue in practice. By default, the on function closes the NO circuit when it is called, so this should be what I need to call in order to turn my green light on, but more on that in just a minute. Another function that you can call instead of on is the close function, which does the exact same thing as on. In fact, close is just an alias function for on, so behind the scenes it's calling the exact same code to operate the relay. Now if thinking about relays in terms of switching things on and off makes more sense to you, then you may just want to stick with the on function in your code. But on the other hand, if thinking about relays in terms of opening and closing circuits makes more sense to you, then you may want to use the close function alias in your code instead. Once you have turned a relay on, you will probably want to be able to turn it off at some point, I would imagine, and you can do that by calling the aptly named off function. By default, this function opens the NO circuit, effectively shutting off whatever device is wired up to the NO terminal. It too has an alias function, called open, that simply just calls the code for the off function behind the scenes, so you can call either one to accomplish the same thing. Again, this is useful if you think of relays in terms of opening and closing circuits versus turning things on and off. And the final function the relay object offers is toggle, which switches the relay between the on and off or open and close states. So essentially, if the relay is switched on, calling toggle will switch it off, but if the relay is switched off, calling toggle will switch it back on. This function does not have an alias, so your only option here is toggle. Alright, now that we know what the available options are, let's put them to use here. Again, the goal here is to turn the green light on when using the on and close functions, and then back off using the off and open functions. Let's go ahead and start with on. Okay, well how about close? Nothing. How about off? Well, that turned the light on, but it shouldn't have. What if I call on now? And the light turns off. Awesome. So what's going on here? Well, remember how I said that the on and off work with the NO circuits by default? Well, they do, but what is happening is that the on function is sending a high value to the input pin on the relay, and off is sending a low value. Well, the kicker is that I'm using an active low relay, which, as I mentioned in the previous lessons, closes the NO circuit when a low signal is received. This is why the off function is turning the light on, and the on function is turning the light off. Obviously, these functions are working properly for the red light hooked up to the NC terminal, but that's not what I'm after here. I want the opposite behavior. I mentioned earlier that there were a couple of gotchas or tweaks that had to be made in order to properly work with an active low relay. The first tweak was modifying the standard Fermata Plus sketch to send a high signal to the relay's pin when the sketch is initialized, and now the second tweak I need to make is to tell Johnny5 to send opposite signals for the on and off functions. Now if you're using an active high relay, then you don't need to worry with what I'm about to do, as everything should be working properly for you at this point. But if you're using an active low relay like me, you'll want to tune into this next piece. Alright, I'll first need to shut down the application here by hitting Ctrl+C twice, and then I'll switch back over to my code to reconfigure the relay object. When I was instantiating the relay just a bit ago, I mentioned that the constructor takes in two types of arguments, a number corresponding to the pin, which is what I'm currently sending in, as well as an object literal containing a couple of different configuration properties. In order for my relay to work properly with the on and off functions, I will need to send in an object literal. The object can contain two properties, pin and type, but only the pin property is actually required. The pin property is pretty self-explanatory and just simply tells the relay object where the physical relay is wired up, which is pin number 12 in my case, the same number I was originally passing into the constructor. The type property is optional and it accepts a value of NO or NC. NO is the default value, so if you omit the type property, this is the value that will be used. And of course, the values correspond to the names of the terminals on the physical relay, so NO stands for normally open, and NC stands for normally closed. This property essentially tells Johnny5 which terminal on the physical relay has a component or device hooked up to it that you would like to switch on and off. Just ignore the fact that I have an LED hooked up to both terminals in this course, because again, in reality, you will probably just use one circuit or the other, not both. So for example, if you have a lamp hooked up to the NO terminal, you will want to plug in a value of NO, or just omit the type property altogether since this is the default value. On the other hand, if you have a lamp wired up to the NC terminal, then you will want to plug in a value of NC. However, this is only true if you're using an active high relay, because when a value of NO is specified for the type property, the on function sends a high signal to the physical relay, and the off function sends a low value. And when a value of NC is specified, the on function sends a low value, and the off function sends a high value. Again, if you're using an active low relay like me, then you will actually want to pass in a value for the type property that is the opposite of the circuit you want to control. So for example, if you have a lamp hooked up to the NO terminal, which corresponds to my green LED here, then you will want to pass in a value of NC. Again, this is because when NC is used, the on function sends a low value to the relay, which will actually close the NO circuit. Since I want to control the green LED, I need to specify a value of NC for the type property. As you can imagine, everything is a lot more straightforward from a coding standpoint when using an active high relay, especially since it seems like the Fermata sketch and the Johnny5 relay class were designed with an active relay in mind, which certainly makes a lot of sense. I chose an active low relay for my demos though, because 1, I have found that they are fairly common, especially when working with microcontrollers, such as the Arduino, and 2, I spent way too much time trying to figure out why my code wasn't working properly when I first got my relay, and I wanted to try to save you from a lot of the frustrations I experienced when stumbling through everything. But anyway, now that I have the proper configuration being passed into my relay object, I should be able to rerun my application in PowerShell and see the on and off functions behave properly this time. Alright, so if I call relay.on, the green LED should turn on this time. Awesome. And if I call off, the green light should turn off. Sweetness. And of course, I can use the alias functions as well, so I can turn the green LED back on with the close function, and back off again with the open function. And let's not forget about the toggle function. Stellar. Well, that's really all there is to show you, so hopefully at this point you can see that even though there isn't a whole lot to working with relays, they can certainly be very useful for programmatically turning things on and off, such as lamps and appliances, or even triggering garage door openers to open and close the doors. Ah yes, endless possibilities. And as always, I encourage you to check out the various resources I've included in the lessons throughout the course for a deeper dive on some of the topics covered, and certainly keep an eye out for more Johnny5 goodness in the course library here at devmashup.com. Thanks for watching.